welcome to Unit 5, Day 3. We're going to be drawing some y equals mx plus b, drawing some lines. Now, we've been reviewing the equations of lines. Yes, last lesson you were identifying what the equations were, what the slope and the y-intercept are. And we're going to do a little bit of review, but today we're going to be doing some drawing. Now, there's a couple of ways. It's a little harder to do these lessons with you in this virtual world. So we're going to try and make a couple of Google slides. I could give you a piece of graph paper and ask you to draw them, which you're welcome to do afterwards. But we'll try it in this frame of, in this Google slide, and you can submit this to me, and we'll see how that goes. Before we get into drawing, though, let's just do a quick little review. I'm going to get you started, but I'm going to ask you to complete this. So just making sure we're comfortable with the y equals mx plus b and how they relate to scenarios. So for example, I've got 6 different scenarios here and 6 different equations at the bottom. So I just want you to, when you get this file, to grab the appropriate equation and put it in the appropriate spot. I'll do the first one with you. Tori charges a $20 registration fee plus $5 per hour for ski lessons. So which one of these equations is it? It's very tempting to look at this one because you see the 20 and the 5 and you might think this, but remember the 20 times x means that the 20 is the thing that changes with every hour, and that's not the case here. The $5 changes with the hour. The $20 is a flat rate. So the flat rates are these numbers here, okay? So this is the appropriate one. So we'll just click and drag it and put it up there. And then we've got $5 an hour plus your $20 registration fee. Okay, and then I'll let you complete the rest, doing these ones, and slide and go over there. If you want to pause the video and go to the file right now, you can, and actually do these, or you can wait till after the video to try them. Okay, so just slide those and move them at there. There is one for each. When we get to the next slide, asking you a couple of questions about that. So here's the one for Tori again. We said it's 5x plus 20. But what if Tori changed her charged $6 an hour instead of $5 an hour, but kept the $20 registration fee? What would the new equation be? So what part of this would change? So I just need you to go in here and type in what the new equation would be. Okay? And then how would the graph be different if we went to this new price structure, this one here, versus the original? Okay, how would the graph be different? Because we're going up by 6s now instead of going up by 5s. And then what if we kept it $5 an hour, so we didn't change it to 6, and we increased her registration fee instead to $25? What's that new equation? And then these last 3 questions go back to these scenarios. So of all these scenarios, this one says which relation is a direct variation. So one of these is a direct variation and the appropriate equation. So you can just tell me which one it is. Number 3 with Lise or Luke or Kim or Danny or whatever. Okay, so just tell me which one's a direct variation. Which one would have the steepest graph? So if you were to graph all these, which one would be the steepest? I think it would be the one with the highest slope or rate of change. So just tell me which one it is there. And then one of them has a slope, or sorry, which one is the slope of Kim's fee structure? So Kim's kind of a special one here. And one of these matches Kim's. What's the slope for hers? So you can just, again, you can just go in here and put your answer right there. Okay, so just a little bit of review on y equals mx plus b so that we're really comfortable to get into our sketching. So I'm going to do the first 4 sketches with you, and then I'm going to leave 6 other ones for you to try. And hopefully these won't take too long, and this is the best replication I thought of for sketching. Now, you've done this before with your scenarios and stuff, so hopefully we're a little comfortable with the tool. So we're going to sketch each of these. So this one is y equals 1/2 x minus 4. So remember, these are all at y equals mx plus b. So the m is the coefficient on x, and the b is the flat rate, the number afterwards. So before we go off and sketch it, I'm going to talk about what the slope is and the y-intercept so that we can sketch it. So I always like to think about the y-intercept first. So the y-intercept is this thing here, and it should be y equals mx plus b, but this is a minus, which means my y-intercept must be negative. So the b part is negative 4. Okay, so that's an important part. And then the m comes in front of the x, and so the coefficient on this, the m is 1/2, so that's a slope of 1/2. So I can delete those, And there's my 2 bits of information. Now I'm going to take this information and graph it. As I said, I like to think of the y-intercept first. So the y-intercept is where it crosses the y-axis. It's the initial value, the flat rate, when x is 0. So this one starts at -4. So I'm going to grab one of these and put it at -4 and say that's where it starts. And then we're going to go off and do a slope of 1 over 2. Remember, slope is rise over run, which means the rise is 1 and the run is 2. So from this point, we're going to rise 1 unit and run 2 units. So I'm going to take my thing here and rise 1 and run 2. Okay? Now, you could even draw the little triangle, the slope triangle, if you wanted. You could, just do it with a pencil if you had this on paper, or just eyeball it out, or you could grab a line tool here if you wanted. I'll just grab a line. It just gets a little bit dicey here. So there's, oh no, see, it's moving. So I think we'll just have to eyeball it. So we're going to just go from here and rise 1 and run 1, 2, and see it there. Okay? So regardless, we get that slope of 1 over 2, rise 1, run 2. And then we're going to take our line and adjust it. So it's about that steep. Put it around here. You might have to do a couple of adjustments. Oh, I did pretty good there. That's pretty good. Okay, if you go and grab one of these, you grab one of these ends and maybe just tighten it up a little bit. Okay, I'm not going to get too stressed out about how perfect it is, but that seems pretty good. Okay, so there you go. You've sketched y equals 1/2 x minus 4. If you wanted, you could always go to Desmos. Just open up a new graph, type in desmos.com/calculator, and you can put that in there. So y equals 1/2, move the cursor over, x minus 4. And look, there's our graph there, and it looks an awful lot like the one we just did. Okay? All right, next. This is y equals -5x plus 3. Again, y equals mx plus b. The m is -5 and the b is 3. So there's our b is 3. And -5, remember, to graph this, we need a rise and a run. So we need to change -5 into a fraction. This one's already a fraction. It's easy to see the rise and run. This one, it's -5. Well, the -5 is the fraction 5 over 1. So -5 over 1. So that means we're going to rise -5 and run 1. So just by me saying rise of -5, that seems really awkward. So that means we're going to go down. Remember, the negative slope means a negative correlation. So we're going to, our rise is -5, which means we're going to go down 5 and over 1. Let's start at the y-intercept. So we're going to go to the y-intercept up here at 3. And then again, we'll eyeball this and go down 5. So down 1, 2, 3, 4, 5, and to run 1. Okay, remember, we always run from left to right. Okay, don't go down and backwards. We need to go down and over. That will make sure we have a negative correlation. If we went down and backwards, we'd have a positive correlation, and this one's definitely negative. All right, so then we can take this and estimate how steep that is. It's pretty steep. Looks like I'm not quite steep enough. Grab one of this and make it a little steeper. And that's pretty good right there. Okay, and then we've sketched that. If at any time you accidentally grab the graph and move it, just push Control Z and it'll put it back. Okay, so that'll be fine. Right, so we've sketched y equals -5x plus 3. So most of the ones you're going to sketch are like these. There are a couple of special cases that I just want to talk about before I send you off. So this one is y equals 2. So you'll see that there's no x there. So this is really like 0x plus 2. Okay, 0x, there's no x. And if you think back to our last unit, we talked about slope. Slope of 0 means it's horizontal. Remember, we're going to do 0 skiing. This one is undefined when it goes up and down. This one is 0 slope. Okay, so this has a y-intercept of 2. So y-intercept of 2 and a slope of 0. All right, so I'm just going to put this back. We know that that's what it is. But we're just going to write it because we'll see it as y equals 2. Now, we're going to go and put our y-intercept is 2 and we don't actually need the other point, but when the slope is 0, this is 0 over anything. 0 over 10, 0 over 4, 0 over 3. So this number can go anywhere we want, okay? It's going to be a horizontal line. So we're going to have to adjust this one big time. We're going to have to turn it all the way around like this. There's a pretty good horizontal line. And we can put it right there. That y equals 2. And it says, no matter what the x value is, y is always 2. So it could be 4, 2. I could move this point. I could move this point over here. It doesn't matter. Okay, anywhere on here. Any point on there. I can even replicate this. I'll just make another one. Put it over here. Okay, all of these are going to be y equals 2. Okay, so y equals 2 has 0 slope, and it's going that way. The other special case then is x equals negative 3. So this doesn't look like y equals mx plus b. Notice all the other equations are y equals, y equals, y equals. Okay, those all have slopes. X equals negative 3 has no y value. There is no slope for this. So the slope for this guy is undefined. Okay, so all you have is x equals 3. Well, when this one we have y equals 2, you just put a bunch of stuff at y equals 2. Well, x equals negative 3 is right here, and since m is undefined, there is no slope. This is a vertical line, okay? And every x is negative 3. Doesn't matter where it is. So I could put it up there. I could replicate it and put another one down here. It doesn't matter. I could put an infinite amounts. All of them are x equals negative 3. There's no y. Okay, so this is the only special case. All the other ones are y equals. They all have y-intercepts. This has no intercept at all and has no slope. Okay, so that's just a special case. All right, so as I said, most of them are going to be like this. So you're going to go off and try it. There are 6 other ones for you to try. You don't have to write the slope down here. You notice I don't have that graphic down there. You can just look at this and tell me what do it in your head. This is a slope of 4, and this is a y-intercept of negative 2. So you're going to start at 2, and 4 is the fraction 4 over 1. So you're going to go from negative 2 up 4 over 1, and then draw your line. Okay, and so forth for these. And then there's a couple other ones for you to try. Once you've done all these, then you're going to push the turn in button. I've hidden it right here. It's going to be right up here near the percent sign. You're going to push turn in, and then we will be done this. There is a couple that you could do out of the book, but really this sketching right here is going to be most valuable. Okay?